Hello, and welcome to Today I Learned Unity, a new series where I teach you about a concept I wish I knew when I was first starting with Unity. The goal is to provide bite-sized lessons with downloadable examples. It is targeted towards more experienced programmers who can use these videos as a filter for Unity's massive scripting API. If you like this content, please like the video or leave a comment so I know whether I should make more. If you have an idea for a good topic, share it with me in the comments. Today's topic is going to be Lerp, which means linear interpolation. To start off, let's define interpolation and note that we're referring to it in a mathematical context. To interpolate something means to determine or estimate a value within a known set of data points. We know vectors can define a position or direction. Suppose we have two vectors representing positions, and we want to move an object between them. You could write your own code to do this, but using Unity's API would be much quicker and safer. Unity's API will also assure that the movement is smooth, which it may not be if you write your own code. My first code example will be demonstrating a simple positional lerp using two functions from Unity's Vector3 class. The first function is just called lerp. It takes in three parameters, two vector 3's called a and b, and a float called t. It returns a vector 3. You can think of a as the start and b as the end. In fact, that's what I called them in the example code. T is the interpolation variable, and it's easiest to think about as a percentage. A float value of 0.0, being 0%, means that the output is exactly a, while 1.0, being 100%, means that the output is exactly b. 0.5, or 50%, means the output is exactly between a and b. The second function is called lerp unclamped. It has the same parameters and output as the regular lerp, only it has a slightly different behavior. In regular lerp, the float parameter t is clamped to the range 0 to 1, meaning a value of less than 0 is treated as 0, while a value greater than 1 is treated as 1. Lerp unclamped has no such check, and therefore would treat a t value of 1.35 as 135% of the way from point A to point B. The lerp example scene has two cubes moving across the screen, with one being driven by the lerp function, and the other being driven by lerp unclamped. I let the t value of the lerp function be time and set the position of the cube to be the output of the lerp function. Unity also has functions on the Vector2 and Vector4 classes to allow for lerping in other dimensions. You must be careful, however, because in 2D projects, game objects still have vector 3's describing their position, which might be counterintuitive. It's important to note that the inputs to the lerp function don't have to be vector positions and time. In my second example, I'm using the vector 4 values to drive the color of a point light and using the distance from the lamp as the t value. I use a vector 4 when dealing with colors because a color has a red, blue, green, and an alpha component. There's one last thing I'd like to mention before I wrap up the video. These vector lerp functions are all driven by mathf.lerp under the hood, which could be interesting to look at if you are interested in how the math actually works. This function simply lerps between two float values. There's also a function called lerp angle, which correctly accounts for angles that wrap around from 360 degrees back to 0. Thank you for watching this video. If you found this content interesting, leave a like, comment, or subscribe for more. If you want to watch me do game development live, I do live streams nearly every day on Twitch. Link will be in the description.